Hello, welcome to this user's manuals video. Today we're going to learn how to operate a FOTRIC mix camera. First, we want to make sure that we have a fresh battery that is fully charged. We're going to insert it into the battery's compartment, making sure that it goes all the way in until it clicks. Now, to remove the battery, to recharge it, we're going to press the front and back button to remove it. Now, we need to make sure that the camera feels comfortable. So while I turn this on, by pressing and holding the power button, I'm going to show you how to get the camera hand strap adjusted. We're going to open, make sure that the hand goes all the way in, so that if it feels comfortable to both press the front buttons and use the thumb to press the front buttons in the main panel. We want to make sure that the knuckles go all the way past the hand strap and that this feels tight so we can operate it with one single hand. Now that the camera is ready to start an inspection, the thermal module can rotate 180 degrees. It can also be kept upwards if I'm going to use the acoustic module, and the acoustic module will rotate 90 degrees. Both of them can be used at the same time or independently. So let's start. For the following demonstration, since we are in a shooting environment, we're going to use a device that simulates an electrical problem. This device emits both audible and ultrasound frequencies. There's going to be some background noise, so just be aware that it is part of the demonstration. Now, I would like to show you how to use the different interfaces of the camera, the different tools and enhancements to be able to identify problems. So right now we are in a control environment where I will pretty much show you how to get to unveil different problems. So let's start. Let's assume that I'm using the picture-in-picture interface where I have the thermal and the acoustic. I can clearly see that there isn't anything of concern on the thermal picture. However, I can clearly see there are some signals appearing on my acoustic interface. I can make sure that there is something right there irradiated on top of that area. So I want to further investigate. In order to do that, I will press the icon on the left side, which will change the interface. Now I'm only on thermal. I will tap once more, and now I'm on acoustic. So I can see there is a signal over there, but on the partial discharge mode, which is the one that I'm using right now, tapping on the fifth icon, the first option, and today we're going to simulate, or right now we're going to simulate, we're doing an electrical inspection. So partial discharge mode is showing me that there is a signal, but the PRPD graph is showing there's pretty much noise. However, I need to fine-tune to identify whether that is true or not. First of all, we're going to start by understanding the frequency filter. What we have on the right side is the adjustment that I can do to have the camera show different parts of the spectrum. Right now I went higher on frequency. I can also go lower on that level, and I can also narrow specific bands. If I do that, for instance, very narrow, I can focus on that one because I know I can see from the histogram that there is a higher amplitude or higher intensity around 40 kilohertz. So that sound source of ultrasound is pretty intense. However, if I keep moving the bar a little farther, that emission or the location of the problem shifts to a different position. This will show me that I can filter out the original source, which is not what I'm interested in, and focus on a different location of the spectrum. Right now my camera is showing one single source, but it is common to start an inspection by using a different mode. A general inspection can start with a general scanning of a substation or electrical room. We will go to the multiple mode, which will show on the screen multiple signals. Now, this can be daunting, especially in certain environments with lots of reflection, like what I'm experiencing right now. I have one source over here, there's one more source over my table, and there are other signals that are appearing and disappearing on the screen. How to deal with this? First of all, we need to understand that ultrasound is a sound wave that can reflect. It's pretty much echo. So we need to be aware of reflection, and by using the digital camera, understand what can be a source of ultrasound and what cannot. A simple structure will not emit ultrasound, but an electrical equipment, especially those insulating components, will. So that will give me a first hint of what is and what is not a true anomaly. Secondly, I will go and adjust the visualization mode. Right now, I can do a general scan, and I know that I have at least 3 sources that I can further investigate. So what I will do next is I will tap on the main menu, switch from multiple mode to either single or hologram. Multiple mode will show the highest frequencies, highest intensities of the signals on the screen. If I switch to single mode, it will only show the highest intensity. Right now we have two competing sources, but this one is still the strongest one, suggesting that that's the true source, while the second one is just reflection. This one goes and this one comes and goes. Now, if I use the hologram mode, it's common to see something like this. The hologram mode shows me a sound map over the digital image. That sound map pretty much shows me the highest intensities and lowest intensities in a given bandwidth. So in order to adjust and make this image make sense to me, the camera uses an auto mode, putting on the top end of intensities the highest source, and on the lower one, the lowest one. So there is pretty much, it's like a range of intensities or amplitudes. If I tap on auto, I can modify that and make it customized. I can modify what are going to be the values from the top and minus or going down. 12 points, 11, 10, and what I'm adjusting right here are the decibels. I want the camera to show me on the screen anything that is the highest amplitude and 10 decibels below. As I keep going down, I'm narrowing that band, and then I'm pretty much isolating specific issues. Now, this is one way to show problems that are within this bandwidth. But remember, if I'm aware of where my problems usually occur, I can also adjust that on the frequency band. Once again, that source is pretty intense. I can see it on the histogram with a peak right around 40 kilohertz. If I narrow that bandwidth, I will start seeing a different issue over there. And as I narrow that specific bandwidth, I can clearly see it. Let's say that I want to further investigate, because it is then, when I narrow the frequency around those values, that I see the PRPD identifying a corona effect. So the next step would be to isolate those specific signals. The next step would be to either go back to single mode to show one single source, but I can still see that reflection coming back and forth. This is what we call competing sources, or competing for leak detection, competing leaks or partial discharge or anomalies in general. So I want to make sure that to remove one of them and analyze a single one. In order to do that, I will tap on the focus mode to analyze that specific one. However, if the two of them are still close to each other, they will still compete within my circle. This mode will remove any signal that is outside of the circle, but it will show and analyze and give me signals based on the spatial location of the issue, the bandwidth that I have chosen. So I want to narrow it even further. I'll go to the main menu, search for acoustic camera device set, and change the acoustic camera focus range from medium to small. Heading back, that circle is now smaller, allowing me to focus even better. Once this has been done, I know that the information I'm capturing is solely from that specific source. Remember that I still have an ongoing source on the left side. If I bring that back in, opening that bandwidth, I can either focus on that one or on the original one that I had over here. You will see some signals that are floating around because the intensity of that one might be higher. And the bandwidth that I'm showing on the screen is pretty much being, the main stage is being stolen by that one. So it's always important to play with the spatial and the frequency. Now that this is ready, I can go on and press the front button, the one in the bottom, and the image will be frozen. By pressing the button, the camera will freeze the image so I can do further analysis or adjustments before I save it. I can tap on the three dots in the bottom part. I can adjust the type of source that I have, adjust the distance from the camera to the fault or the problem. Label it as a favorite. I'm going to do that because that's indeed a problem. I took a picture, I want to make sure to remember it. I can add voice notes, comments, or tags. We will go into these later. Now that the picture is ready, I will press the picture button once more, and my image is going to be saved. Now, you notice that I played by adjusting the bandwidth. What if I have already identified through my training, my experience, that the specific problems in my specific facility or with the equipment that I'm dealing with usually occur in the same bandwidth? The camera allows me to save specific ranges of frequencies that I can save as a preset. Let me show you how to do that. First, I will go to the main menu. I will tap on Settings, find Acoustic Device Set, and then go to Frequency Configuration. I will tap right there, come back, and you will see that on the bottom left corner, there is a little icon saying Default. If I tap right there, I will now see this plus icon. The plus icon allows me to choose one specific range that I'm interested in saving. I can adjust, make it narrower. Come here, tap on plus, and call it, this is the range where I usually find Corona. Save it, and then even if I change the mode of the camera, let's say to leaks, and then come back to partial discharge, and the camera goes by default to its default range, which is 20 to 60 kilohertz, which is quite broad, I can narrow it back to the specific values that I'm aware of and that I know. Another important part of evaluating the type of problem that you're identifying with the acoustic module of the camera is setting up properly the frequency of power on the given country where you're doing inspections. Right now I'm using a system that works on 50 Hertz. But if the frequency is not properly set up, the AI on board won't be able to detect what type of problem it is picking up. So let me show you how to do that. Right now, as you see, it is showing 50 Hertz corona effect with a 90% certainty of that being the problem. I will go and switch on Settings, Acoustic Camera Device Set, Acoustic Camera Frequency, and I will switch from 50 to 60 Hertz. When I go back, the camera will switch to 60 Hz and then I'm getting a different reading. That's why it's very important to set this properly. In some cases, you will pretty much just find noise or an abnormal problem or nothing at all. So it is important that before you start using the camera, you set this properly. Another important key measurement when I'm doing an inspection is the level of intensity, amplitude, or decibel levels of a given problem. This will help me to determine what's going to be the priority during the maintenance and repair process. So let me show you how to do that. We're going to go on the settings, and I will ask the acoustic device to show the decibels value of a given signal. Right now it's giving me a signal of 40. If I were to stop using the focus mode and my amplitude, the range of the frequency was going to change, and I'm showing multiple signals, now the camera is showing me the different intensities and amplitudes of the different signals. Now, we said that in given environments like the one that I am right now, this is not recommended. But I know that with the right adjustment, I can measure specific problems. Right now I have one single source and I have some reflection on the back. Let's say that that's a second problem and I want to measure the two of them. By pressing the picture taking button, I can press it once more and those values will be saved into the image. But in addition, I can measure different components or different faults so that that information is captured into my report. To do that, I will go on the settings, device set for the acoustic camera, and I will go to measurement enhancement. I will turn on the measurement tool, and this will enable this third icon with spots and areas of interest. If I move this spot to a given signal, it will read the specific decibels values on that specific location. If I move the area to another signal, it will give me those readings as well, always within this frequency range. See what happens with this area when I bring back the specific frequency in which that source is emitting. I immediately get the amplitude readings for that specific bandwidth. So once that has been done, I would like to add a second area over here, right there. I would like to narrow it a little bit more, eliminate one of them, and take my picture. I can further adjust that and say these are the measurements on those two, or let me just move this spot, let me just leave it in the middle as a reference and say at this given frequency range, these are the decibels measurement or the sound pressure level of those two sources, indicating that this is the one that I'm interested in and this is the actual problem that I want to address. I will press the picture taking button and now the image is saved. One of the advantages of ultrasound is that it can help you find problems earlier before they start even showing heat anomalies. So having the combination of the two systems complement each other and helps you assess having two technologies on your hands. So what happens when there is a problem that is just starting? There is, let's say, a floating or surface discharge that is just starting to occur and is not strong enough to be constant on the screen. That problem will show in an intermittent way. Let me show you one tool on the camera to address those and facilitate an inspection when you're doing the general scan stage. First of all, I would like to clean my screen. I will go right here and eliminate all of those. I will also like to make sure that I'm working on the right frequency. Remember that I changed it earlier. Acoustic device set, acoustic camera frequency, back to 50 Hertz, which is the system that I'm currently using. Now, I would move to settings, acoustic camera device set, measurement enhancement, and I will turn on the TFF-TD. This is a proprietary technology on the camera that allows to differentiate or to enhance or remain on the screen signals that are not constant, but that appear and disappear. So right now, the camera is assuming that the signals are constant and they keep appearing on the screen. I will switch to the second mode, which is called on the screen transient source, which is a source that appears and disappears. See how the image is changed. Let me adjust the bandwidth right here for a second. Let's go back to my Corona right there. And see that the sources went from being intermittent, as we saw them here, jumping around, to be something more stable. To give you a better example, let's imagine that this is a source that appears and disappears. You can see how the sound remains on my hand even if I remove that hand from the scene. The signal appears and remains for a couple seconds, so when I'm doing the general scan, I can still identify it. See what happens when the mode is off. A brief signal can be overlooked, and I might have missed it, or I might think that it is just a reflection. Once again, this is a mode that is recommended when you're doing a general scan. Once you see something, let's say right here, once you identify something, you can circle back and analyze further using, for instance, the focus mode. For the following part, we're going to learn how to use the camera to identify and measure leaks. So first of all, I will go and switch to the leak mode. When I go on leak mode, I want to make sure that I'm using the default mode first. The default mode goes from 10 to 50 kilohertz. From 10 to 20 is audible range. From 20 and above is ultrasound range. So you can see that this is quite a broad spectrum. So first of all, you can start the scan with this range, but once you identify something that has called your attention, you can narrow that span to a given area or modify the specific level. On the right side, you will see the frequency filter, which has a peak on intensity around 40 kilohertz, which is precisely the specific frequency of that emitter. Commonly, when we do inspections, we will start with multiple sources, which will look something like this. So I will start by scanning around, looking for problems. When I do that, I can see three sources, two of them in given devices, and the third one in something that doesn't seem to make sense as a leak emitter. If I move even farther, I might see leaks in other places like the light or even the screen on the back. The best way to analyze whether a source is an actual leak and not reflection is by moving the camera around and detecting whether those signals remain in the same component. That is why we have a digital camera. If you notice these two signals, no matter if I move the camera, the colors will always remain on the same component. But when I look at this one, every time I move the camera, the signal will appear on a different part of the table. That's a clear indicator that that is reflection. After I have identified those specific sources, these two, I can further analyze by tapping on the signal mode, go to single, and it will show me the specific one that has the highest intensity. I can also keep it in multiple, but then use the focus mode. To use the focus mode, I will tap right here and analyze this one or the other one. To isolate specific sources, we really identified that these two are true sources while this one is a reflection. I can use two methods. First, I will switch the general visualization to a focused visualization. I can tap on the focus mode, which I can adjust in size by going to settings, acoustic device set, acoustic focus range, and change from, let's say, small to large. Now we have a wider range, which is not useful for this specific case. So I'll go on, change it back to small. Acoustic, small. When I'm using the focus mode, it is very useful to work on single mode. So I'll switch from multiple. I already know where they are, and I'm going to analyze one by one. The camera is going to show me the sources in this specific bandwidth and within this area. So I can analyze that one or the second one. That way I can take a picture of this one with a given decibel value that will determine my leak level, save it, and then focus on the second one, which has a different intensity and a different leak level. Aside from the single and multiple mode, there is a third option called hologram. The hologram gives us a deeper understanding of what I'm seeing in front of the camera. So let me show you how to use that. First, I will start by turning off the focus mode. I will move to the first icon, the acoustic parameters, go to signal source mode, and switch to hologram. By default, the camera will show this type of image. It shows colors everywhere, sometimes can be daunting. What the camera is doing is creating a sound map overlaying the digital image. It's showing the intensities of or amplitudes of different sources of sound within this frequency range. So I will first adjust the range that I'm interested in, say higher or lower. Right now I'm in the audible sound. So pretty much what you see there is the reflection of my voice. If I go to the specific frequency range of my emitters, which are around 40, it will focus on the same three spots that we saw earlier. Now, the camera is on auto mode, which means that it's taking the highest decibel value of the screen and give a color even to the lowest ones on the screen. It's an auto range. I can also tap on auto and make it manual, going from as wide as 12, meaning 81, which is the highest, down to 69 or 68. But if I close that range, now I'm having 80 minus 7, around 73, 74, for the specific values that are going to be shown in that sound map. See how all the colors disappear, and now I focus on a specific one. This helps me to find leaks that are around the same level of intensity. It's like filtering the background noise. If I have a given source of sound that I don't want to see on the screen, first, of course, I will isolate by arranging the frequencies. If there's, let's say, vibration sound, rumbling sound, which occurs usually on the lower frequencies, I can eliminate that first by bringing it to the specific frequencies where I am detecting my problem, and then narrowing down to pretty much eliminate anything that has a lower amplitude or a lower intensity on this specific frequency range. You see that as if it becomes smaller, the signals that will appear are less and less. As I mentioned, when you activate the leak detection mode, the camera will set up itself for a specific default frequency range that in this case goes from 10 to 50 kilohertz. However, if you have identified that in your facilities or for certain specific equipment or problems, there are specific frequency ranges or points that is where you can find those problems, you can adjust those values and save them as a preset. Let's say that for this specific situation, I have problems occurring at 40 kilohertz. I can narrow that down, bring it very close, or adjust the level at a given point. And then I can add that as a preset. I want to make sure that I go to Settings, Acoustic Camera Device Set, and then I will tap on Frequency Configuration right here. Right now it's already turned on, which means that on this bottom interface, I will see the Add button. I will tap it and type a name for my preset of frequencies. Let's say leaks, save it, and now even if I using default mode, I can quickly switch, tap in right here to leaks, and that preset will automatically be loaded. In addition to determining where a leak is located, you may also want to consider having an estimate of how much that leak is costing to your company so that you can also decide the priority on fixing them. In that sense, we're going to go now to the leak detection mode, but a specific one for evaluation, which is on this icon. I will tap enter. Now the camera will automatically go on a specific frequency range. And in order to get an accurate estimate, I will go to Settings, Acoustic Device Set, Leak Evaluation Parameters, and I will set these values up. The leak correction factor can be set in 1 unless adjustments are needed later on. The currency will remain there. The energy cost is the cost of the kilowatt hour that your company is paying to keep the compressor system running. Sometimes it is based on a state, sometimes it depends on the way that your company gets the power from. The gas cost applies to specific types of gases other than compressed air. The specific power, if you don't know this value, we're going to keep it on 30, which is a regular efficiency for compressing systems. Flow rate unit, CFM, can also be changed to liters per minute. And the runtime, this is assuming a 24/7 operation on the system. So now that the system has been configured, we're going to simulate a small leak, and we will see it occurring on the screen. Right now this leak seems to be $54 a year, but if the leak becomes larger, we will see how the price increases. After the leak is gone, you also want to make sure that the distance between the camera and the leak is properly set. This is very important so that the estimate is more accurate. I will go to the main settings in the bottom, tap on distance, and I will adjust that. Let's say that I'm not standing as close as I am right now, about 4 feet away, but I'm detecting that leak around 23 feet away. See how the values of the estimate change by adjusting that parameter. See how the value has been multiplied, and also the camera is giving me an idea of how big the leak is in flow, the leak level, and the cost. Let's say it one more time. So with this tool, After creating multiple pictures of the different leaks that you have determined, your report will give an idea to the maintenance and reliability team of which leaks need to be addressed first. To prioritize the order of leaks that will be repaired in the plant, I will go to the leak evaluation mode, set up the parameters as we learned earlier, take the picture of the leak. I have taken a picture of a leak. I want to link this to a specific asset, compressed air line, or to a specific leak repair request. Once the picture is frozen, let me just redo it. Picture is frozen. I will tap on the menus to open the tags interface. And if my camera is connected to the Wi-Fi already, I can use OCR. The OCR will capture anything that is inside that window. So I want to make sure to make it to the size that I require. Let's say this one. I don't want anything else by the first 2 lines. I will hit click to take the picture. And now the camera has recognized both the number, which was on the first line, and also the second line. I will confirm that, save it, and now I'm ready to save the picture. I will press for the second time the picture taking button. Let's say that I continue with this process and I identify a second leak or any other leak. Remember, it's very important to always adjust the distance because that will affect the cost of the leak. Let's say that now I'm closer to a particular leak. Excuse me. Enter. I will take the picture of the leak. Now I have a leak of a lower cost. Once again, I will repeat the process, but this time, if this is going to be my methodology to link leaks to leak repair requests, then I can simply set up the AI shortcut button to do that step by step for me. I can either add a QR tag or an OCR tag. The OCR tag, we saw it already. Then when I press that button, it will automatically open that. I'm going to also show, for instance, the text annotation or just a regular tag. I will use regular tag this time. I will press enter. And let me just show you the process once more. Leak detected, picture frozen, tap on AI. This time I will simply type. It's going to be the tag number, saved, and I will save the picture. Don't place some back. If I go to my gallery, I will see all the pictures that I have taken previously. I will tap on funnel and I will see the specific leaks that I have found. So if I want to identify the 01951 leak that it took first, I will tap here and there I'll see it. But if I want to see a different one, I tap the different tag and then I will see the second one. Now let's talk about the thermal module of the FOTRIC Mix camera. Some of you have multiple lenses to go from wide angle applications to ultra telephoto applications. In order to change those lenses on your camera, we're going to go to this part. We're going to lower the latch over here, press lightly, and rotate counterclockwise. We need to perform this operation while the camera is turned off. I will remove the lens, put the lens cover, take the new lens, and find this red dot that is over here. We will align that red dot with this other red dot in the lens cavity. We will find the place where the lens falls into the cavity gently. We're just going to do a light push, rotate clockwise until we hear that click. Make sure that the lens is properly installed and that the latch is also back into the original position. Now we can turn on the camera and start inspection. Let me show you how to get your camera in focus to get a good picture. First, we're going to use the focus ring on the left side of the camera. We can adjust it by simply using our index finger. Here I am adjusting to the specific location where I need it. But I can also use the autofocus on the camera. To employ the autofocus button, we're going to press the top button on this area. We're going to click it once and wait until the camera is in focus. First, I'm going to make the camera out of focus for the sake of demonstration. I will press the button once, and the camera will show those two brackets on the screen showing me the moment the camera stops focusing. I can also adjust what type of focus the camera uses. Right now, the camera is using thermal contrast to identify edges that the camera will recognize so that the picture is in focus. However, the camera can also use the laser ranger to do that. So let's go to IR device, focus. In autofocus, I will choose laser. When I go back and I press the focus button, the laser distance ranger is going to measure the distance between the camera and the flat surface in front of me to get the camera in focus. I press the button and the camera goes in focus. You know that the laser focus is activated because you will see a small dot in between the brackets. There you go. If I were to change the type of image, like I'm going to do here for blending, you will also see the laser dot appearing on the screen. The camera also comes with touch focus. A common reason for which thermographers prefer to use. Let me show you a third way to use autofocus. A common reason thermographers prefer to use the manual focus is so that they can focus on specific components that are closer or farther from the camera, which sometimes the autofocus cannot get. I can also use the autofocus by going to IR device set, focus, touch screen focus. When I choose that option, I can tell the camera where in the screen I want to focus. Let's say I'm going to aim a little farther, tap over there, and the camera will focus at that distance. If I return to my original position, you will see that the black body and the cup are out of focus. I will tap on the cup and my image is focused on the cup. If I tap on what is behind the cup, now you will see the sharp edges on the back while the cup is out of focus. The second factor that you want to set up in your camera before you start any inspection that cannot be changed after the picture has been taken is the temperature range. Focus and temperature range are something that you need to make sure to get right during the inspection. If I go to the settings on the camera, I can choose what type of temperature range I want to use and which level. For this particular model, I can use intelligent range, which will help the camera choose which of them two is more suitable. Remember to try to always keep the smallest range and also the one that is closest to the temperature you're working with. In this case, I'm going to switch to the lowest one, and you will see it reflected on this part of the screen. After setting out the temperature range on the camera and the focus for your image, we're going to proceed to adjust the emissivity. We're going to tap on the three dots in the bottom part to open the main menu, open the parameters, and then emissivity. There are two areas that I can use to do that. I can adjust the emissivity by scrolling on the values from 0.01 all the way to 1.0. There are also some materials that can be used as reference. We always recommend you to research for the specific emissivity of your material or to find it experimentally. I'm going to choose right now a low emissivity just for the sake of demonstrations. I will tap enter to activate it. In order to see temperatures on the screen, I can do one of two things. I can add an ROI, like a spot right here, place it anywhere on the screen, and measure that temperature. Right here is showing me the temperature and the emissivity of that specific spot. If I also want the maximum temperature in the entire scene, I can go to the menu, settings, look for the IR device set, and then look for the image overlay. In the image overlay, I can show a number of things on my screen. Let's say the global maximum temperature, the emissivity of the entire screen, and let's say other additional factors like distance and let's say humidity. I will go back, and now those values will appear in the bottom part of the screen. The maximum temperature in the scene is appearing in the top left corner. The temperature of the spot is going to appear second. Notice that I have the same emissivity for both the spot and the general scene, 0.2, 0.2. If I have a specific material with a different emissivity, I can tap on the spot, tap right here, and while the spot is selected, I can tap for a local emissivity. I will turn it on, adjust the emissivity to a higher value, and then click on enter. Now the emissivity of my spot is different. Additional parameters can be adjusted before or after taking the picture. I can also access the menu by tapping the center button, moving with the directional buttons, open the parameters, and adjust the reflected temperature, for which I will just simply scroll, ambient temperature, humidity, distance, and IR window compensation. To activate the IR window compensation, I will click, turn it on. You will see that it's activated because that little icon appears on the top left corner. I will adjust the temperature of the optics and then the transmittance rate of that specific window. After clicking enter, the values on the entire screen will be adjusted. Once your parameters are in place and we're ready to take a picture, we can adjust the span and level of the image. First, I will go to the main menu, temperature scale, choose auto. This can help me to do a general scan to identify specific areas of interest. Most users prefer to switch from auto to manual so that they can control the top and lower level of their range. If I tap the top one and tap also the bottom one, you will see that this one is gray and this one is black. This one is unlocked while this one remains fixed. I scroll on the screen and I can adjust that value. Then I can either use the same method or simply use the directional buttons to switch from the top one to the bottom one. I can also use the directional buttons going up or down to adjust the value. If I tap on the right directional button again, the two of them will be locked or unlocked simultaneously at the two of them. Now I can either move the scroll or the directional buttons up and down to adjust my level. Another way to do this is by choosing the auto mode, going to the settings, IR device set, and activating the TWB mode. Now the camera will show me details that were previously hidden about the lower temperature objects. Even though there's a high temperature area on the screen, I can see clearly more details. Let me show you the difference once again. The TWB is particularly useful in environments when small components appearing on the screen are at very high temperatures. Lastly, I would like to show you the touch span. With the touch span, the camera will use a specific area of my interest after I signal it with my finger. Let's say that I'm interested in this particular area. Now the colors will adjust for the temperatures on that specific region. If I tap again, let's say on this area, it will use those temperatures to give me details on it. If I go now to this one, I'm interested on the temperature distribution of this object. So all the colors are focused on those ones. I can also repeat the process of pressing the directional buttons to adjust the top, bottom, or the two of them at the same time. And if I cannot find the right spot, I will simply tap again on the specific area. If I personally like to switch from auto temperature span or manual or touch continuously, instead of doing that process of opening 1, 2, and 3, and 4, I can set up one of the AI buttons on board to do that for me. The first one is in the front, and the second one is in the bottom part of the lens right here. By pressing and holding the button, I will open the interface to set up which function I want as a shortcut. In this case, I'm gonna go find switch scale mode. I will click, and when I press that button, it's gonna start changing just by clicking on the button. So I start on automatic, switch to manual, and now using the directional keys, I can adjust my level or my span. Then I switch again to touch, and the process is much quicker. I would like to show you now how to use regions of interest, ROIs, like spots, circles, and rectangles on the camera. I'm gonna go back to auto scale. I will tap now on my ROI. Here I can add one spot. I can also add one rectangle. I can locate the spot, let's say, in an area of reference. I can tap on the center of the rectangle and move it around in a specific region that I'm interested in. By tapping on the corner, I can adjust the size and shape of that box. And I can also add other type of shapes, like a circle or a line. By tapping in the center of any of the figures, I can adjust the position, and by tapping on the edges, I can adjust the size and shape. Now I have a rectangle, a spot, a circle, and a line. I can use these figures to calculate the temperature on different parts of my scene, as you can see on the left part. I can also use them to calculate delta T's between components. I don't need to do them one by one or by pairs. I can simply tap here, ROIs, delta T. I will turn on the delta T calculation, and I can use two methods. One is to use the temperature of one of my elements as a reference. Let's say spot 1, click on enter, and now the temperature of spot 1 becomes my new reference. Now, the temperature values that you see on the left side belong to the difference between area 1 and spot 1, circle 1 and spot 1, and the same for line 1. That means that I'm doing delta T of 3 versus 1. Another way of doing that is by choosing, let's say, the minimum temperature on circle 1. Now the reference is not the hottest spot, but the coldest one. That becomes my new reference point. The second method is not using an area's temperature as reference, but a fixed temperature value. Temperature rise would require for me to also set up a specific value. So I would say I'm gonna fix it in maybe 50. Enter. And now the temperature reference is 50, and all of these are comparing versus 50. I can also use these ROIs to measure area and distance between components. I will clear my screen first by tapping right here and deleting all of them. I will add, let's say, one circle, to measure this specific area. And I will add a rectangle for this specific area of interest. Let me just adjust the diffusion for a second, right there. If I use the laser pointer, which is in the bottom part of the lens, right here, aiming at my area of interest, first I need to focus to get the two images overlapping. And by pressing the laser pointer and holding it, automatically measures the distance between the camera and the surface, but also gives me the area and distance of different components. Since I have two-dimensional figures, like the two on the screen, what I'm reading is areas in square feet. If I want that information to be saved on the picture, I will go to Settings, Storage and Save Options, Save Distance Measurement Information. That way, when I focus the camera will use the regular focus that I have chosen. And when I press the focus button, the camera will measure. That information of the laser distance will also be stored as the distance for the specific picture. And by pressing the picture button again, the image is saved. Another useful and quick way to identify problems is by using the ROI's temperature alarms. First, I will tap on a specific area. I will open the sub-menu of that area, open the alarm interface. For this one, I'm going to set up the high temperature alarm. The maximum value, if it fulfills my condition, which is being above, let's say, 73, if I hit enter, then that value will change to red. If I bring that, let's say, to this one, we will see how the color disappears. I'm going to bring it back. And I can do the same for low temperature. This is particularly useful when I'm working with equipment which temperatures I need to control. I will tap on this one right now. Alarm, turn it on. For this one, I want to control that it doesn't go below certain temperature value. So I will set up the values as well. In this case, I want it to buzz. Hit enter. If the temperature is below what I expect, it will produce that sound. By scrolling down, I can lower the volume of that sound, both for the main speaker of the camera or for Bluetooth earphones. Oftentimes we want to control multiple processes, multiple components in a scene. For that purpose, we will use multiple ROIs and delta T's. Let's say that I have many of them that I will organize aiming at different objects. When I am monitoring multiple processes or components, especially in industrial environments, it is common to have multiple areas of interest on the screen. I can keep doing that and without adjusting or modifying anything, get a quick, clear and big picture of what is going over there. I will simply scroll down on the screen and tap on Hide. Automatically, everything will be hidden. I can take a clear understanding of the thermal image and then bring everything back on. You also notice that there is an additional icon called Super Resolution. The Super Resolution will enhance the amount of pixels that are included into a picture for higher details. The flashlight can also be activated from the drop-down menu on the screen. This flashlight is particularly useful when I'm exploring industrial environments that are dark, where I want to add additional digital pictures. After I am done with the measurements with these areas of interest, I will tap right here and delete all of them simultaneously. The FOTRIC mix cameras come with two different digital cameras that will complement the infrared and acoustic cameras. The first of them is right here, and the second one is over here. Let me show you how to use them. First, I will go to the main menu, image mode, and I have multiple options. The first one is thermal. The second one is blending. For blending to work properly, I need to make sure to focus the camera at the given distance of interest. I can tap on the 60% and adjust the level of transparency that I want for my image. I can also change to picture-in-picture, adjust the shape, size, and position of that specific area. Or I can simply open the digital picture for a wider view. If it is common in my inspections to do this over and over, I can also set up one of the AI buttons as a shortcut. I will set it up for, let's say, switch image mode, click enter, and then I will simply tap on that button to go from thermal to picture-in-picture, blending, only digital, and so on. The camera can either take a single thermal picture or the combination of both thermal and digital. I will go to the main menu, settings, storage and save options, save digital image as a separate. Now when I do that, the moment I take a thermal picture and save it, it will show the two images that were taken, the digital and the thermal. If providing good quality digital images for my team is important so that they can quickly find the specific component that needs to be fixed, or they want to get better context of what is surrounding the area of interest, I can take pictures using the flashlight on the thermal camera without using a secondary light. To do that, I will go to the main menu, settings, device set, and turn on the LED lamp as flash. Now, when I take the thermal picture, the camera will activate the flash so that my digital picture is well illuminated. Different environments will require different levels of brightness on my screen. If I'm working outdoors, I want a bright screen to be able to see details, so that I don't have to cover with my helmet or with my cap to be able to see the screen. In lower light environments, like industrial settings, I might want the brightness of the screen lower. To do that, I will scroll down from top to bottom and slide on the level of brightness on the screen. Not only this will enhance the performance and the experience on the field, but it will also save the camera some battery. If I'm not going to use the thermal camera for some time, but I don't want to turn it off to make sure it remains stable on its ratings, I can simply tap on the power button once and the screen will go off. By simply tapping again, the screen will start again and I can continue with my inspection. As soon as I take a picture, I might want to tag it so I can quickly find it in the gallery. I can open over here, and I can also use tags to link them to specific assets. If my camera is connected to the Wi-Fi already, I will open the OCR, aim at those specific parts of text that I want to scan. In this case, I will want, let's say, the first two lines. After that has been aligned, I will take the picture. The camera will recognize those two lines, location and electrical panel. Confirm, and I can save that as a tag. I will know because the tag is showing on that corner. Picture taken again, now my image is saved. Let's take a picture of a second asset. I have taken the picture, and if this is going to be my standard procedure, picture taking and tagging, I can set it up with one of the AI buttons. I can do directly, let's say, a QR tag, OCR tag, or general tag, so I can get to choose every time. So my picture has been frozen, not saved yet. I will press the AI button. The interface is open. The scanner for QR codes is much faster. It recognizes automatically, and I get the asset number right away. I will save it. The tag is saved. Picture taken again, so that the image goes to the gallery. I can also use barcodes. So I'm going to take a third picture. Image is frozen. I will open the tags interface. And this time I will use the same scanner, but for a barcode. Now the information of the barcode has been stored, saved, the tag is part of the picture, and I press picture taking button again to save it. If I go to the gallery, I will have lots of pictures, but I can filter them by asset. I will go to the funnel, find a specific asset number like A724847, and I will see the pictures of that asset. If I do another picture of the same asset, let's say 2 or 3 months later, and I scan once again the QR code or barcode of the asset and save it, when I go to the gallery and filter for that specific one, in this case is the EP4563 from the QR code, and confirm, it will show me every single picture that it has been taken for that asset. I would like to conclude by adding some additional comments and recording videos. I have just frozen the picture. I can open right here, and from a different position or in a more comfortable place, I can do the adjustments that I want. This is a simple picture with no elements, but before the picture is saved, I can do the adjustments that I require. I'm gonna add a few reference points over here. I can also add voice notes. By tapping here, the camera starts recording using the integrated microphone or the Bluetooth earphones that can be connected to it. Once I finish, I can listen to it from the speaker that is integrated on the camera. For that, you will have to adjust the volume as I showed earlier. I know there is a recording already there, and I'm ready to save my picture. Remember, if you want to add a tag, you can do it over here. You can also add text annotations that can be input in different ways as well. Now I'm ready, and I will save the picture. If instead of pictures I want to record videos, there are 2 ways to do that. I can capture, instead of radiometric pictures, I can record standard videos. Right now, the chosen option is MP4 because it is for non-radiometric videos. If I want a radiometric video, I will want to go to Storage and Save Options, Video Format, and switch to FOTRIC's proprietary radiometric video format, IRS. You will see the new icon on top of the screen. I will start recording. I stop with the same picture taking button. I can review my video before saving it. I can also add measurement components, like let's say a line. I want to use this line to control temperature of, let's say, a process. And the maximum temperature on the line will appear over here. Remember, the video hasn't been saved yet. Now, after I'm satisfied with the result, I can also add additional notes and save the video. The video can be also edited after the fact. If I tap the gallery button, I can open that video. Remember to eliminate the filter. I will open that video, and from here I can even add more measurement objects. I can change the palette because the video contains all the temperature points on the image second after second. Another way to take advantage of the camera's recording capabilities on the longer period of time is by going to Settings, Capture Mode, time-lapse. For long processes or where I want to control the temperature differences on a specific equipment from being recently installed or zero baseline temperature to its functioning temperature, I can set up intervals. Let's say I want to take a picture every 5 minutes. 5 minutes, 0 seconds. And I want to take from 2 to 1000 frames. Or let's just say unlimited, so I can stop it myself. I will start the picture taking process, and the camera will take a new picture every 5 minutes. So I don't think that's gonna help for the purposes of the videos. Let me just change real quick. Capture mode, time lapse. I'm gonna bring it back to maybe every 2 seconds. Right there, enter, go back, start recording. Then after 2 seconds, the second image is taken, third, fourth, fifth, and I can stop at any time. 7 images have been saved in a period of 7 seconds. I will confirm when I go to the gallery, all those 7 images will be saved together. Well, some of you like to save the images by number, sequential number, day after day. Some of you prefer to have both date and number on the image file. For that, I will go to Settings, Storage and Save Options, File Naming Format, and switch from name by number, as it was, to name by date and number. Now when I take a picture, it will be named with the date and the number, following a sequential number that is going to be reset back to 0 every new date. Different applications require different palettes to be able to make visible different types of problems. To change the palette, I will go to the main menu, tap right here, and these are going to be the most commonly used palettes. I can also tap on the 3 dots and see all the available palettes on my camera. On this one, I have white representing hot and black for cold. But the palette can also be inverted by tapping on this corner. Now, I have black hot and white cold. This is being applied to all the palettes simultaneously, so you can choose which one is going to be more convenient for you. In the bottom part, we will see a special type of palettes like above temperature alarm that will help me by changing this number identify areas of interest that are exceeding a given temperature value. I can complement this by using the blending mode and see those areas of interest. I can also choose the below temperature palette or condensation palette, tap on that number making it blue, bringing it up or bringing it down. And with the combination of the blending mode, it makes the visualization much insightful. After your inspection has been completed, you may want to extract that information back to a computer or a backup. To do that, we're going to go to the lower part of the camera. Over here, we will remove the area cover. We will press and remove the SD card. The camera will come with an SD card reader. I will plug it right there and connect it onto my computer to extract all the images and videos for the thermal and acoustic modules. Then I can insert it back in. The second way to extract data from the camera, like images and videos, is by the USB cable. It can also be used to connect to our softwares, so you can control the camera in through a wired connection. The USB will go right in the middle, and then it can be connected to your computer. You can also live stream the display of the camera onto a projector or a larger screen by using the HDMI interface. We're going to use the micro HDMI side of the cable, plug it onto the right side port that is underneath. It is very important that you use certified cables and preferably the cable that comes together with the camera to ensure performance. With that, by using the HDMI cable, I can live stream non-radiometric video. Using the USB cable, I can live stream radiometric video onto the computer with one of our softwares. Or I can use IR Explorer to live stream radiometric and non-radiometric video onto a mobile device of any brand, like a smartphone, a tablet, or a laptop. For how to use that, we recommend you to go for the specific videos on IR Explorer for more details. The proper adjustment of the hand strap of the camera will make sure that the camera will feel comfortable and the operation is going to be easy. That's why we're going to open, adjust, make it tight, pass in the knuckles, and that way I can use the camera even with just one single hand in different positions and for different types of applications. The camera also comes with a neck strap. Even though this is comfortable enough, for long days of inspections or when I need two hands to open panels, I can install that. So let me close that and show you. The first step is to remove the battery. We're going to use this small area to pass the loop of the neck strap. I will make sure to bring this end over here, then under, and then bring it back so it is completely secure. Make it tight. And now the battery can come back to its position. For the other side, I will repeat the same operation, but here we will do it on this side. When the two sides of the neck strap have been adjusted, including the reverse back loop, the camera should feel secure enough to be used. I'll bring it onto my neck. I can adjust the length over here, and that way I can use the camera around, either holding it with my hand and the hand strap, letting it rest on my abdomen, operating facing forward where I'm looking down on the screen, or doing different types of operation. Once I am done, the camera can rest back on my abdomen.